We should now talk about inverse trigonometric functions. The rationale for learning about inverse trigonometric functions is the same rationale as for inverses of functions in general. So what happens is that in many situations we'll want to find an angle having a certain property, and the method will be to undo the action of a given trigonometric function. So for example, suppose that we have a triangle like this. So say this is a triangle, and this side is 1, this side is 2, and we're trying to figure out that angle right there. So if you think for a second what trig function I should use to relates these three things, from SOHCAHTOA, it is actually the cosine. And writing down what that gives you, you would get cosine of theta equals adjacent, so adjacent, over hypotenuse. So you get that cosine of theta is a half. So what is the angle then? Well, this should look familiar because there is a special angle whose cosine is a half. And if you pull from your memory, you should remember then that the angle is actually pi over 3, if you're using radians, or 60 degrees. So because there is a special angle whose cosine is a half, we were able to figure out this problem. That angle measures 60 degrees. Done. But what about if I have other numbers in there? So for example, if I had something like 8 and 10. Well, in this case, we would get cosine of theta equals 8 over 10, adjacent to our hypotenuse, which is 0.8. But there is no special angle whose cosine is 0.8, so what is the angle then? We still want to know. So what we do is we introduce inverse functions. So we want to undo this cosine so I can just have the angle all by itself. We want to get rid of that. You get rid of that by doing the opposite. We want to undo that. Okay, so that's what we want to talk about inverse trigonometric functions. So let me remind you then a few things about inverse functions from college algebra. First of all, the notation. If you have a function f, the inverse function is denoted by f inverse. And remember that that is not an exponent, that is just a notation. And an inverse function in general is a function that will undo what a given function does. Now, inverse functions do not always exist, but they exist. We know that they exist when the function is 1 to 1. So if f is 1 to 1, then the inverse function exists and we call it f to the negative 1, f inverse. And also the inverse function has some other properties. It basically reverses what a function does, so it swaps the x and the y's. So if you have a function whose domain is x and whose range is y, then the inverse function is going to swap these. So the range is now the domain of f inverse, and the domain of f becomes the range, which is basically what property 1 is telling you here. The domain of f inverse is the range of f, and the domain of f, which is this, is actually the range of f inverse. So it swaps the x and the y. It not only does that with the domain and the range, it also does it with the variables themselves. So if you know that f of x equals y, then you can pass to the inverse as long as you swap the inputs and outputs. So the output is now an input, and the input is now the output. So an inverse function swaps inputs and outputs, and you can go in either direction. If you start it with f inverse, then you can pass to the original function f by just swapping the x and the y. The input is going to become the output is going to become the input. And that would be property 2 right there. We'll talk about property 3 and 4 later. Another thing that I want to remind you is, when is a function one-to-one? We want to know that because a function that is one-to-one is going to have an inverse. So recall from College algebra that a function is going to be one-to-one when its graph passes the horizontal line test. That means that every horizontal line that you can imagine passing through the graph will cut the graph only at most one point. If it cuts the graph at more than 1 point, 2 or more, then it's not one-to-one. Okay, so let's look at then the graphs of our trig functions, the basic three, sine, cosine, and tangent. Starting with sine, well, here's the graph of sine. That graph definitely does not pass the horizontal line test. Okay, it does not pass the horizontal line test because if you think about any horizontal line passing through the graph, it will cut it more than once. So for example, the x-axis itself cuts it up here, 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 and then forever, because this goes on forever. So infinitely many times, not just one. So that means it actually fails the horizontal line test spectacularly. This function, the sine function, is not one-to-one. Similarly, if you look at the graph of cosine, that also fails the horizontal line test horrendously. Take any horizontal line, it will cut the cosine graph more than once. Okay, so this is not one-to-one either. It does not have an inverse. And lastly, if you look at the graph of tangent, this also is not one-to-one. If you imagine any horizontal line, it's gonna cut the graph infinitely many times. This is not one-to-one either. So what to do then? Okay, so there's a solution to this problem though. What you do is, instead of looking at the entire graph of sine, you just focus your attention on just a small piece of the graph. So restrict your attention. So I'm cutting here a piece of paper. What you do is you restrict your attention only to a piece of it. This piece right here that I drew in blue. If you restrict your attention to only that piece that goes from negative pi over 2 to pi over 2, then, okay, this blue right here, then that passes the horizontal line test. So it would be one-to-one. So if you take the domain of sine and you restrict it from negative pi over 2 to pi over 2, that is going to be one-to-one. The range of that, the vertical span, it still goes from negative 1 to 1, so the range is still from negative 1 to 1. But the point is that on this piece, it is one-to-one, thus it does have an inverse function, and we call that the inverse function sine inverse, following standard notation, or you could call it the arc sine. That is also another very popular way of writing the inverse function of sine. So you could write sine inverse, sine to the negative 1, or arc sine. Okay, same you can do with cosine to solve the problem. So cosine does not pass the horizontal line test, but if you focus your attention to the piece, to the interval from 0 to pi, so just that piece, then it will become one-to-one, and it will have an inverse function. So if you restrict your attention from the interval from 0 to pi, this piece, then that passes the horizontal line test, so it is one-to-one, and therefore it has an inverse function. We call the inverse function of cosine, restricted to that, cosine inverse, or arc cosine. And lastly, for tangent inverse, that is not one-to-one because it fails the horizontal line test, but if you restrict your attention only to the interval from negative pi over 2 to pi over 2, these two asymptotes, then that piece there is one-to-one because it passed the horizontal line test. So it has an inverse function called tangent inverse or arctangent. And you have to memorize that, okay? You have to memorize I need you to memorize the intervals where you restrict your attention to. For cosine, you restrict your attention from 0 to pi. For sine, you restrict your attention from negative pi over 2 to pi over 2. And for tangent, you restrict the domain from negative pi over 2 to pi over 2. It is very important that you memorize that. So let us write it down. You should write this down. Okay, let me grab a piece of paper and let us write it down. So you should memorize this. What you should memorize? The domain and the range for each of these three functions. So sine inverse goes from -1 to 1, and it goes to negative pi over 2 to pi over 2. Cosine inverse, the domain is from -1 to 1, and the range is from 0 to pi. And the tangent inverse goes from negative infinity to positive infinity. That's the domain. And the range is from negative pi over 2 to pi over 2, but not including the endpoints. Okay, so you should memorize this. You should memorize that. So let's explain a little bit more what this actually means. The domain being between -1 and 1, that means that you cannot plug in numbers that are outside of this interval. So for example, if you try to plug in 2, 2 is not between -1 and 1, so that means you are not allowed to plug in 2. It doesn't make any sense whatsoever. If you plug in 2, this does not exist. It is nonsense. It is undefined. Okay? Similarly, if you try to plug in a negative number, so if you try to plug in -3, that is nonsense. Okay, -3 is not between -1 and 1, so this is not going to exist. Okay, so that's one reason why you should memorize that is a domain of sine inverse, because you should know when something like this makes sense or not, if it is nonsense or if it makes sense. For tangent inverse, there's no problem whatsoever. For tangent inverse, you see the domain is from negative infinity to infinity, so that means for tangent inverse, you can plug in anything whatsoever. It will always make sense. For sine inverse and cosine inverse, that is not the case. For sine inverse and cosine inverse, only numbers between -1 and 1 make sense. The calculator will give you error. Okay, now what about the range? Well, the range means that's where the output is going to live. For example, sine inverse, if you plug in something that makes sense, sine inverse is going to spit out an angle between negative pi over 2 and pi over 2. So that means whatever it's going to give you back is going to be an angle between negative pi over 2 and pi over 2. It's going to be an angle in quadrant 4 or quadrant 1. It is impossible for sine inverse to give you an angle in quadrant 2 or 4. Okay, so it will only give you an angle between negative pi over 2 and pi over 2. Cosine inverse is always going to give you an angle between 0 and pi, and you have to memorize that. An angle between 0 and pi, quadrant 1 or quadrant 2. It is impossible for cosine inverse to give you back an angle in quadrant 3 or 4. And lastly, for tangent inverse spits out angle between negative pi over 2 and pi over 2. So similar to sine inverse, but the difference is that it can never be negative pi over 2 or pi over 2. It can never be one of the endpoints, because at those points you have asymptotes. So you don't get an actual point, or you have an asymptote there. So that's why you can never get that back, the endpoint. So memorize this, and once you have this down, we can solve some examples.